All right, so our lesson for today is we're going to be looking at right triangles in context. So our objective says I can solve context problems involving a right triangle. So context just basically means word problems. But this is really our lesson 10-2. Like where we're finding like the missing side, I give you a variable. But we're adding context. So mathematically, you already know how to do these. Now it's just adding a word problem to it and then writing a sentence conclusion, okay? So you guys already know how to do like the math portion of it. Now it's just the only difference really is like adding a sentence at the end, okay? All right, so I didn't even hear what you said. Okay, so all right, so for today we're going to be looking at strategies to solve word problems. Our first thing you want to know is figure out what is it that it's asking you for. So identify the unknown, and then you're going to attach the variable to whatever side of the triangle it goes with, okay? And then you want to label the sides, the opposite, adjacent, and hypotenuse side. It's going to give you an angle, so then that'll help you figure out the opposite and the adjacent side. And then you're going to write an equation using sine, cosine, or tangent. So sine is so, cosine is ca, and then tangent is toa. And then you're going to solve the equation. And then at the end, go back and read the problem again and figure out what was it that it was asking you for to be able to write a sentence conclusion. Okay? So if we look at our first example here, I'm going to read the problem. And I'm going to highlight what I think is important. If you don't have a highlighter, there's highlighters in the bin back here. Or you can just underline. Underlining it works as well. So this one says a lamppost is 12 feet tall, which I can see the lamp right here is 12 feet tall. And then it says find. Find is the key word right there. That's what I'm looking for. So find the length of the wire that runs from the top of the lamp post to the ground. So my wire is actually this side right here. Okay. From the top of the lamppost to the ground, that's the length of my wire. That's what I'm being asked to solve for. Okay. And then the directions say here to round to the nearest tenth if necessary. So I need to figure out where to put my X. I know that this is 12. This is what I'm looking for. So when it says find, that's where you want to put an X. So I'm finding the length of the wire. So that's where I'm going to put my X up there. Okay? All right. Now that I know where my variable is, now I have to do just like we did for prior knowledge. Go label the sides as O, A, and H. So here's my angle. Across the angle, is that the O, the A, or the H? O. Good. Across the 90 is which letter? H, which leaves us with A down here. And then for SOHCAHTOA, we have to figure out which letter we're not using. A. A has nothing attached to it here, so I'm going to cross out A. I don't have cosine and I don't have tangent. That leaves me with sine is opposite over hypotenuse, because I don't have anything given to me on the adjacent side. All right, and then we're going to write our equation just like we were doing on our last lesson here. So S, what does S stand for? Sine. Sine of the angle. What's my angle? 33 degrees equals the opposite over the hypotenuse side. So what's the opposite side? So 12 over You can use W, you can use X, whatever variable you want to use. But yes, the variable in the denominator. We just saw something like this on the prior knowledge. So what do we do with the fraction here? Multiply both sides by X because that's in the denominator, okay? That way the fraction cancels here and we end up with X times sine of 33 degrees is equal to 12. Is my variable by itself? No. So what do I do to get it by itself? Divide by sine of 33 on both sides. Okay, sines cancel, and I get a X is equal to, again, calculator, what does the fraction mean? Fraction means to do what on the calculator? Divide. So we're doing 12 divided by sine of 33, close the parentheses, and then press equal. Okay, so on the calculator, 12 divided by sine of 33, close parenthesis, press equal. Yeah. Okay, righties, go ahead and tell your partner what you get for your answer to the nearest tenth. So after the decimal, one number. Righties? Tell your partner what did you get for your answer. All right. On a count of 3, I want you guys all to tell me the answer. Ready? Tell me in 3, 2, 1. 22. That was kind of sad. I didn't really hear you guys. 22, yes? But it was like 22.03 something, right? So technically, you're supposed to put the 0.0 to show that you are rounding, okay? And then so far we've done units, like just UN, because we didn't have units, but now we do. Our units here are feet. So I'm going to add feet to my answer. Okay, then I have to go write my sentence conclusion. So go back to the question and figure out what did we just solve for? What does this 22 represent? This is my wire, right? This is where my X was at. So if you look back at the question, the word find, what did we just find? We found the length of the wire, right? So just write your sentence. We say the length of the wire is about 22 feet long, or you can say the wire is about 22 feet long, okay? So the wire is about 22 feet long, period. Notice I use the word about because we don't know for sure. Well, plus is an estimate. We rounded our answer, so we always want to use the word about 22 feet long. Okay? Not too bad, right? Like I said, you already know how to do all this math that we did. All we're adding now is just a word problem, so now we have to write a sentence conclusion. That's really the only difference, though. Okay? All right, so now I want you guys to look at our next example. On our next example, we have 2 trees here. So I'm going to read the problem and see what it's asking us to do here. It says a person is standing 30 feet away from 2 trees. So I can see my 30 feet right here. That means my person, I'm going to draw a little stick figure right here. My person is standing right here, 30 feet away from the two trees. And then it says, my question is, how much taller is the larger tree than the smaller tree? My question is, how much taller is the larger tree than the smaller tree? So I want you guys to take a look at this question and think of, like, how do you think we're going to solve this problem? If I ask you, like, let's say you have a sibling. Not everybody here has siblings, but if you did have a sibling, if I ask you, how much taller are you than your sibling, how would you calculate that? So go ahead and Lefty, tell your partner, what do you think we're going to do to solve for the difference in heights for the trees? All right, so again, that's good. We are going to take the bigger tree's height, and we're going to take the smaller tree's height, and then we're going to end up having to subtract them to figure out how much taller the big tree is, okay? Now, but if you notice, I have like two triangles right here, and they're overlapping. Sometimes that can be confusing, so I'm going to split them into two different triangles. If you notice this big triangle here, I'm going to highlight it in green. That big triangle, I am going to redraw it on the side over here. Not as big as the original, obviously, because then I won't have room for all of my math. But I have that bigger triangle. I just separating it from the picture. This length right here is this length right here. That's the length or the height of the big tree. So I'm going to use B for the big tree. So B is representing the height of the big tree. That's just so you know, that's what B stands for. B is the height of the big tree. I still know that this is 30. And then I need to figure out what this angle is right here. So if you look at the big triangle, I have to figure out what this angle is. I know from here to here, this is 56, and from here to here is 18. So how can we figure out the total angle here? Add. What's 56 plus 18? 74. Good. Okay. So now this is for my big tree. I'm zooming in just so you guys can see. We're going to do SOHCAHTOA here. So here's my angle. Across the angle is O. Across the 90 is H, which means 30 is my A. So for SOHCAHTOA, which letter can we cross out? H. I don't have an H. So I'm left with TOA. What does T stand for? Tangent of my angle, which is 74 degrees, is equal to the opposite side, which is what? This is my variable. I'm using B, so I'm putting B. And my adjacent side is 30. Okay. My variable is in the fraction, so I need to multiply by the denominator. So what do I multiply both sides by? 30. Good. Multiply both sides by 30. Those cancel. I'm left with 30 times tangent 74 degrees is equal to B. Is my B by itself? Yes. Am I finding a side or am I finding an angle? A side. If you're finding a side, you use regular trig. You're not using the inverse. So no second sine or tangent. You're just using regular tangent on the calculator. Okay? So you're going to do 30 tangent 74, close the parenthesis, press equals. So 30 tangent 74, close parenthesis, press equals. Okay. Righties, can you tell your partner what you get for your answer to the nearest 10? All right, eyes in front. On a count of 3, tell me your answer. Ready? Tell me in 3, 2, 1. 104.6, I heard. Did anybody get a different answer?
Are we able to put 105?
You want to keep it to the nearest 10th. The directions say nearest 10th. Right here. Nearest 10th. Alright, and this is feet. I just found that the bigger tree's height is 104.6 feet. This is only so far the height of the big tree. Alright, now I'm basically going to do the same thing for the smaller tree. So now I'm going to look at the smaller tree. So if you look at the smaller tree, it has this height here. And then has this hypotenuse. And this side over here. So you guys see the blue triangle? Now I'm going to redraw the blue triangle on the side. I forgot to label. So this on the big triangle is B. So now for the smaller triangle, I'm going to use S for smaller triangle. Okay? So S right here. This is still 30. And then now what's the angle right here for the smaller triangle? 56. Good. So put 56 degrees right here. And S is going to be the height of the smaller triangle. Or smaller tree, sorry. Height of the small tree. That's what S stands for. Okay? Alright, then you're basically going to do the same thing we did for the big tree. Figure out if this is sine, cosine, or tangent. Okay. I have the O, the A, and the H labeled. Which one can we cross out? H. Which means we're left with which trig function? Tangent. This is a TOA. So I want you guys to practice now. We've done this for a little while now. So I want you to practice now finding the small tree's height. The work for the big tree is still right here, so you can check the work what we did for the big tree. Go do it now for the small tree. Alright, so I got the same thing. I got 44.5 feet for the small tree. Have I answered the question yet? The question was, how much taller is the larger tree than the smaller tree? I have not answered that yet. So far, I only have the bigger tree's height and the smaller tree's height, but I haven't figured out how much taller it is. What did you guys say, though? What should I do to those two numbers? Subtract them. I am going to use like a capital D for the difference. The big tree minus the small tree. That's going to be 104.6 minus 44.5. Which is going to be 60.1 feet. My units is still feet. Now this is my final answer, but I have to write a sentence conclusion, okay? So I want you guys to practice writing a sentence take up maybe what, like 15, 20 seconds to write a sentence down. Again, the context says how much taller is the larger tree than the smaller tree. That should help you write your sentence. For the sentence, we're going to say the larger tree. And your sentence does not have to be exactly like my sentence is, as long as you answer the question, okay? So the larger tree is about 60.1 feet taller than the smaller tree. Okay. All right, so again, one more time. We ended up having to get the bigger tree's height by separating the bigger triangle. And then we separated the smaller triangle to find the height of the small tree. And then once you have the two heights, we subtract them to get the difference in their heights. Okay? All right. So now we're going to move on to this next example where we have the fire truck right here is like 10 feet tall. And then here it says we have a ladder on top of a fire truck. It's fully extended to reach the roof of a burning building. So the ladder, notice, goes from here to here. It's on top of the fire truck. It does not go all the way to the ground. And then it says we have a burning building that's 50 feet tall. This is 50 feet, okay? But if you notice, we have the triangle right here. So I'm going to redraw the triangle. Here's my right angle. I have 65 degrees right here. My ladder, that's what I'm looking for. How long is the ladder? Round to the nearest tenth. So my X is really going to be right here. Okay. I know that this is 50. I know that this is 10, but how much is it from here to here then? 40. Okay. That's actually 40 right there. So in order for me to find X, here again, we ended up doing 50 minus 10, because from here to here is 10. That means that this side is 40. Now we can use SOHCAHTOA to solve for X here. Okay, so what's across the angle? Opposite across the 90 is H. And then we have the adjacent side down here. We don't have an A, so what trig function is this one? So sine of 65 is equal to 40 over X. And then we always multiply by the denominator, this times X. Equals 40. Then divide by sine. Those cancel. Now my X is by itself. Go put that in the calculator. 40 divided by sine 65. All right, and what did you guys get for your answer? 44.1, thank you. My units is feet. So we're going to say the ladder is about, oh my God, I can't write. The ladder is about 44.1 feet long. Okay. In this case, I knew the height of the building and I knew the height of the truck, so I ended up subtracting them, right? But if we look at the practice problem, our next one, does anybody need this though? Or I forgot to ask. You guys are good? Okay. If we look at the next one, this one is saying a person who is about 1.8 meters tall is flying a kite. And then it says to estimate the height of the kite above the ground. That's really asking for this from here to here. That's the height of the kite above the ground, okay? And then it says when the length of the kite string is about 60 meters. So I can see my 60 meters right here. And we're supposed to round to the nearest 10th. So if you see the triangle is really right here. So redraw your triangle. Here's my right angle. Here's my 60. This is 31. And really, I need to find this height. I know that this is 1.8 from here to here. I can find this height using the triangle here. And then once I get this, then I can add 1.8 to get the total height, right? So this I'm going to call x. So to get the total height, I'm going to have to take my x value and we're going to add the person's height of 1.8 meters. And that'll give me my total height above the ground for the kite. Okay? So you guys are going to go finish this problem and see if you can solve for your final height. 32.7? No, for like 30.9, right? For x? What trig function did you guys use? Sine of 31 equals x over 60, right? So you should have had x equals 60 times sine 31, which gives you about what? 30.9, I think, meters. So if you do 30.9 plus the 1.8, that should give you 32.7 meters. And then don't forget to write your sentence. So you would say the kite is about 32.7 meters above the ground. Okay. So if you finish this one already, you guys should be able to do the assignment now, the whole thing. So for homework, you guys are doing 10-4, not 10-2. 10-4. You're doing all problems now.